Hi everyone, welcome to week 3 live session of NPTEL Digital Circuits. I'm Omeshwari and today we will solve some questions that may help you in your assignments as well as in your upcoming exams. So let us start. So in this week, basically we will focus on mainly K-map and Boolean identities and a little bit introduction to logic gates. So let us go solve some questions now. If you have any doubt at any time, please feel free to unmute yourself, and you can also write your questions in the chat. First question is, which of the following is the correct simplification for the function f p q r s equals to pqs plus p dash r dash s dash plus p bar q plus p bar r s bar plus pq s bar. So we can use K-map to solve this question and find the simplified form. So we also solved some questions of K-map last time, so I hope you all are familiar with them. If anyone has any doubt in K-maps, you may ask, but just give this question a try, then we will solve it. Okay, let us solve this one together. So if someone does not know how to do K-maps, okay, so let me add a page. Right, so the function that you have f equals to pqs plus p bar r bar s bar plus p bar q plus p bar r s bar plus p q bar s bar. Right, so we will make a k-map. We have four variables p, q, r, and s. P bar q bar p bar q p q p q bar s s r bar s bar r s bar bar s bar. Okay, so if we number it, it is 0, 1, 3, 2. Okay, we don't need numbering here, so okay. So now I will identify where uh, these each of these terms which where do they lie, right? So it is p, q, and s. So we have p, q in this row, and s is in these two rows, right? These both are s, and this is p, q. So both of these will be 1. So wherever we find these literals, we put ones. We have two ones here. Next is p bar, r bar, s bar. So p bar is here. So all of this can be p bar. Then we have r bar, s bar. R bar, S bar is this. So these two should be 1. Then we have P bar Q. Again, this is P bar. This is Q. So this is P bar. This is Q. Simply this is P bar Q. Whole of this will be 1. Then we have P bar R S bar. This is P bar. Then we have R S bar. This is R S bar. Both of these should be 1. Next you have P Q bar S bar. P Q bar is this, and S bar is this and this. So these two will be 1. Now what you have to do, so this was the first step. Step 1, mark ones in Kmap. Step 2, make largest possible groups of 2, 4, 8, 16, and so on. Groups of 2 to the power n. Okay, so let us make some groups then. Right. So first group we want to make largest possible group. So first group I can directly see is this, right? Group of these four, and this is Q here, and this is S. So this is Q, this is S, and this is QS. Okay. So
QS plus P bar Q.
next we can see, right, these four. So at the corners also we can like combine these four entities. So let
Q
me
bar S bar.
put some color here.
Q bar S
So
bar.
say these four. So this is Q bar, Q bar.
S bar.
So
Q
these
bar
both are
S
Q
bar.
bar and these are S bar. Right. So these four are Q bar, S bar. Now only these two remain. So what we can do is form a group like this. It will be
P bar Q.
P bar Q. So your answer could be F equals to QS plus Q bar S bar plus P bar Q. Right. But what we can also do, we can do one more thing. Right. This, sorry. Okay, Harshal. So what we have done till now, we uh, marked ones according to these uh, terms. We marked ones in the K-map. Then what we have to do, make the largest possible groups. Groups of 2, 4, 8, 16, right? Groups of 2 to the power n terms. So like these are four ones. So I will always take to make largest possible groups. Yeah, sure. I'm explaining the marking. So uh, as in by marking, do you mean how did I fill these ones? Okay. So okay, let me start again. Right. So first, so we have four variables: P, Q, R, and S. And let's say PQ we take this side, R and S we take this side. Then what we do is we label each row with some combination of P and Q. Right. So this is basically PQ, sorry, P bar Q bar, P bar Q, PQ, PQ bar. Similarly, up here we have R bar S bar, R bar S, R S, R S bar. Now I am labeling like this. It is like what do you say? This is 0, 0, 0, 1, 1, 1, 1, 0. Here also 0, 0, 0, 1, 1, 1, 1, 0. So this kind of labeling is like we label the K map in gray code. Right? In gray code, this is 0, 1, this is 2 actually, this is 3. So first step is this. You just give the labels to the K map. Next step, what your function is, that is what you want to solve with K map. PQS plus P bar R bar S bar plus P bar Q plus P bar R S bar plus PQ bar S bar. So this is the function that we want to solve using K-map. So we take one term at a time and identify where does the term lie in our map. So it is P, Q, S, right? So here we identify where do we have P. We have P at these two positions. So that means all these 8 columns will represent P, correct? Then we have Q. So but PQ. is like these four columns. Then S, S is we have S here, we have S here. So this is PQ, this is this is S. So their intersection is PQS. So I will put 1 and 1 at their intersection. So these two represent PQS. Is it clear? Azim? Right. So similarly, what we do is for P bar, R bar, S bar. So the P bar is here, P bar is here. This whole top eight columns or top eight cells can be P bar. Then you have R bar and S bar. You have R bar, S bar here. So the intersection is only here. So we will mark once here. So we have done this and this. Next is P bar Q. P bar Q, this whole row is P bar Q, right? This is P bar Q. So we'll mark once here. Next we have P bar R S bar. Again, these top eight columns are P bar. Then R S bar is what? This is R S bar. So their intersection will be one now. Next we've done this. Last is
Q
P
bar
Q bar
S.
S bar. So we have P Q bar is here. This whole row is P Q bar. S bar is here and here. So these two are the intersections where we will need to put ones. Correct. So this is how we fill these terms. We have marked these terms. Next step is we want to make largest possible groups. Right. So somebody asked, what is step two? Right, Harshad, what we have to do? We have to make largest possible groups of 2 to the power n ones. Right. So let me do this again. So just by looking at it for the first time, I can see this is like the four ones are here together. I can make it in one group. So let me just mark it with some color. So these four are ones are in one group now. Now, now what does these four ones represent? That I have to identify, right?
US.
So then only I can minimize the expression. So what does this identify?
US.
Here we see, yeah, here there is Q and Q. So that means this whole two rows are Q. And here we see S and S. So these whole two columns are S. So these four blocks are QS, right? So this is QS. This four terms represent QS. Next is what we can see here, right? So maybe we can also form these four into one group, right? So these at these corners we have this is Q bar, this is Q bar, and this is S bar and S bar, right? This is S bar and S bar. This is Q bar and Q bar. So these four intersections are Q bar S bar. Q bar S bar. Now only these two ones remain which are ungrouped, right? So we can group them. Just say I group them like this. Then this is simply P bar Q, right? This row is P bar Q. So your answer can be F equals to QS plus Q bar S bar plus P bar Q. This is fine, Harshad. Do you get step number two? Azim? Okay. So this is one of the answers. But one thing to note here is the last group that we formed. So let me remove it. Uh, Okay. For these two ones, we have one more option. What we can do is form a group like here, right? This is also four ones together. So let me make this one also. And this is
E bar, S bar,
this is P bar,
S bar.
and then this is S bar, right? This whole was P bar, and this was S bar. The intersection is P bar S bar. So I'll label it as P bar S bar. So your answer could also be QS plus Q bar S bar plus P bar S bar. So both of these are correct. So this is also correct. This is also correct. So your option is Q bar S bar, QS, P bar S bar, or Q bar S bar. So both A and E are correct. So you need to be little careful when the question, if the question has both an A and E, it may be possible that both are correct. So you need to check for both the options. Is this clear to all? All right. So let us move on to the next question. So the question is, A, B, and C are Boolean variables, and F is a function such that this is the expression for F. You have to find the complement of F. You have to find F bar. So what you can do is, first you may minimize F using either Boolean identities or K-map. Then you will get some F in minimized form. Then just take F bar. That will be easier. So attempt this once, then let's see. You guys try with K-map. I will solve it with Boolean identities. Let me know if anyone face any difficulty in solving this with K-map.
So the answer is none of the above.
No, no. Okay, so since this is since this is not in SOP form, it will be difficult for you first time to make a K-map out of it. So let's just try this one with Boolean identities first. Right? So let us solve it. You have F equals to A bar plus B plus C, B plus C bar, A plus B plus C. Right? So first step, what you can do is multiply these two. So you will get A bar B. I multiplied these two. I'll multiply first A bar with these, then B bar, then B with these, and then C with these. A bar B plus A bar C bar plus B plus BC bar plus BC plus CC bar. Then you have A plus B plus C here, right? So CC bar will be 0. And in the remaining terms, let us take B common. You have A bar plus 1 plus C bar plus C, right? And here with this remaining term, A bar C bar, this whole is multiplied with A plus B plus C. So here what you have is 1 plus some terms. So 1 plus all terms will be 1. So you will get is B plus A bar C bar into A plus B plus C. Now again multiply, you will get AB plus B plus BC plus A bar AC plus A bar BC bar plus A bar C bar. So I've just multiplied each term. So you can say the CC bar will be 0. This A bar will be 0. So you will have AB plus B plus BC plus A bar B C bar. Again take B common. You have A plus 1 plus C plus A bar C bar. Now again 1 is added with something, so it will all will be 1. So your answer F is D. And what you had to find F bar. F bar will be
E bar.
B bar. So your answer is B bar. Okay, so how are you getting none? What mistake did you make? Is it clear now? Are you able to identify a mistake? Haven't done F bar, right? So the question asks for the complement of F, right? So you need to be mindful of the questions in your exam. So please read it carefully. Anyone else has any doubt in this? Sure. Then let us go to next question. The simplified expression for the given these terms will be what? So what you can do is maybe just do these multiplications and then make KMF. So step 1 here is multiply for SOP form. Step 2, make KMF. So just take a minute. Okay, let us multiply together. Then you guys make KMF and tell me the answer. We have W bar, X bar, Y bar plus Y W bar, WX bar whole bar plus W bar Y plus WX. So I can write it as W bar X bar Y bar. Now we can apply De Morgan's law here, right? This is something whole bar, so I can write it as Y W bar plus X bar also bar plus W bar Y plus W bar X. This is 0. You have W bar X bar Y bar plus W bar Y plus WX plus W bar Y. So this is same, I will ignore this plus, then this is Okay. Okay, I did something.
This is yx.
Yeah, yeah, it is yx.
Yx.
Yes, it is yx, y into x. So this is your final expression that you need to make KMAP of. Anyways, at this stage, you can just solve it manually also, but let us try to solve it with KMAP so we can practice a bit. So anyway, three variables. You have three variables, w bar and w, x bar, y bar, x bar, y, x, y, x, y bar, right? These are my three variables. Now, this is the function I want to make KMAP. First is w bar, x bar, y bar. This is w bar. This is x bar, y bar. So here, I put a 1 here. Then you have w bar x. This is w bar. And these two are x.
W bar y.
Oh, sorry, w bar y. This is w bar. This is w. This is y. So these two will be ones. Then you have yx. What is yx? This is xy
So
is yx. So these two will be ones. Now we just need to make groups, largest possible groups. So one group could be this, simply xy. Then another group could be this. This is w bar x bar. So your answer is w bar x bar plus xy. This is in simplified form. C option. Uh, are you not able to see my screen?
yes,
Screen is visible, right?
yes, yes.
I think Azim, there's some problem with your connection. Can you maybe just reconnect? Okay, there might have been some network error. Anyways, so we just form these two groups, and this one is w bar x bar, this one is xy. Answer is w bar x bar plus
Plus
xy.
x bar.
It's
Sir,
option.
can we have three terms also?
No,
C.
the groups can only be in the number of ones in groups can be just 2 to the power n.
No, no. What I'm saying is, in order to remove the hazard, we can have another grouping also, a third grouping. That can be Y W bar. Because C option is that also, and last option is both A and C.
Oh, right, right, right. Uh,
No, but there it is not matching. A is not matching.
C, A and C, right? No, no, A is not the answer, I think. X
Sorry,
bar, Y
A is
bar,
not there. So it
X bar,
cannot
Y
be.
bar, X bar, Y bar will be this, right?
Yeah, yeah.
So only this is the only correct answer. Right, that, but that is a good point. If there is a both in the question, we need to be mindful to see if it is the case or not. But here, I don't see any possibility of any other group, right?
Yeah, but if the three options are, the three terms are also there, in order to remove the
No,
hazard, we
then
can select the grouping. No?
this is not minimized. If we
Yeah,
can
yeah.
have something in two terms, then that is the minimized expression.
Okay.
Is there anything else? Any other doubt?
No, sir.
For the Boolean function f a b c d, f equals to ab plus a bar b bar c, what will be the corrected form of SOP? So basically what you have to do is just make this into K-map, and wherever you get ones, you give those numbers. So if you remember these numbering, so I'll make the K-map with the numbers now. Then you can tell me the answer. We have A, B, C, D. So let's take A, B here, C, D here, A bar, B bar, A bar, B, A, B, A, B bar. This is C bar, D bar, C bar, D, C, D, C, D bar. Now, how do we number this? So we know, right? This is 0, 0, 0, 1, 1, 1, 1, 0. This is also 0, 0, 0, 1, 1, 1, 1, 0. Now, since it is A, B, C, D, I'll assume like this is my MSB, this is my LSB. So the numbering should be something like A, B, C, D, 0, 0, 0, 0, right? This column is 0, 0, 0, 0. So it is 0. 0, 0, 0, 1 is 1. 0, 0, 1, 1 is 3. 0, 0, 1, 0 is 2, right? 0, 0, 0, 1 is 1. 0, 1, 1 is 3. 0, 0, 1, 0 is 2. That's how we number these. Is this numbering clear to all? So in a similar fashion, we will number all these, all other these. This is 0, 1, 0, 0. 0, 1, 0, 0 is 4, right? So then you have 0, 1, 0, 1. This is 5, 0, 1, 1, 1. This is 7, 0, 1, 1, 0. This is 6, 1, 1, 0, 0. This is 12, 1, 1, 0, 1. This is 13, 1, 1, 1, 1 is 15, 1, 1, 1, 0 is 14, 1, 0, 0, 0 is 8, 1, 0, 0, 1 is 9, 1, 0, 1, 1 is 11, 1, 0, 1, 0 is 10. Okay, so these are the actual those min term numbers that we see in these answers, right? So is the numbering clear to all how I have numbered all the boxes? Uh, as in, is it clear to you? How do we number these boxes? Okay, so it is like very difficult or a waste of time to just combine these and check. So it is always, you can just remember the sequence. It is 0, 1, 3, 2, 4, 5. So, okay, you can write 0, 1, 2, and 3. Always the last number is always in the third block. 4, 5, then 6 and 7. Then in 4 variable K-map, we go to the last order. 8, 9, 10, and 11. Then 12, 13, 14, and 15. So it will be easier if you just remember these numbers. Where do they come for you in your exams and assignments? Okay, so now we have AB plus A bar B bar C. We have to fill this in here. So where is A? This is okay. This is AB, and you have, so you will have ones here. Make ones, one, 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 and one. Then you have A bar B bar C. This is A bar B bar, and this is C. So these two, B1 and 1. So your min terms are 2, 3, 12, 13, 14, 15. So your answer should be option, this option. Is it clear to all? All right, just go ahead. The minimum number of literals present in the SOP product for Boolean expression this is. So literals is nothing but the number of variables that are there in a term, in a in a in an expression. So like here we have 1, 2, 3, 4, 5, 6, 7, 8. So you have 8 literals. And what the question is saying, you minimize this, then how many literals are there? Right? How many variables are there? Okay, do we already have two answers? Three. We have three literals here. Have you minimized it? Krishna and
Sir,
team.
no, no, it is wrong.
These are three terms, not three literals. Literals are eight. You have to minimize it and find in the minimize function how many literals are there. Okay, Harsha got the right answer, AB plus A bar C bar. So you can just make a key map. A, B, C, A bar, A, B bar, C bar, B bar, C, B, C, B, C bar. You have AB. So this is A, this is B. So this will be 1. Then you have A bar, B bar, C. This is A bar, this is B bar, C. And you have A bar, B, C bar. This is A bar, this is B, C bar. Is there a question, Vaibhav? Okay, so now we just make groups. This is one group, and this is one group. This is
Sir,
A,
only three terms are there. Then how come here four ones are come?
what?
Only three terms are there here. But how come four ones came here?
Yeah, sure, we
Four.
can make the groups again. So you have AB plus A bar, B bar, C bar plus A bar, B, C bar. This AB, you see, it is a three variable schema, but it has only two variables. So it must have additional ones. It basically means ABC plus ABC bar, right? This AB. So here you have A here and B here. But you see, it is C plus C bar both. So that's how just this term gave you two ones.
Okay, 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 right.
Okay, right. So now let's make the groups again. This is one group. This is AB. This is one group. This is A bar, C bar. So your answer is AB plus A bar, C bar. Okay, Dina, now you are again giving the wrong answer. You have literals are, please.
Hello, Emma.
Okay, so you have 1, 2, 3, and 4. 4 literals. Literals is simply just number of variables in expression.
But sir, there are only three variables, the A, B, and C.
That's right. Literals is like the individual all that you are getting.
Okay, where the sign does not matter, whether it is
No.
plus or dot. Okay.
So answer is 4. As we saw in this expression, right? I told there are 8 literals. Just because they are like 8, 1, 2, 3, 4, 5, 6, 7, 8. You just have to count the number of uh, any variables in your
Yes,
minimized
yes.
expression. So basically the question was not about literals. So this is not a very important thing. The question was about minimization again. So I don't think you will be asked some question regarding literals. Okay, so let us see the next one then. What will be the correct product of sums for Boolean expression mentioned in question 5? So the expression was AB plus, what was it? A bar B C bar plus A bar, sorry, A bar B bar C bar plus A bar B C bar, which we minimize to AB plus A bar C bar. Now the question says, what is the TOS of Boolean expression, right? So in the earlier question, it was asked, what is the correct SOP form, right? Then we chose this numbers. Now it is the opposite. This is product of sums. So if you see your in your K map, A bar A, B bar C bar, B bar C, B C, B C bar. We already know these are the ones. But if we number it, this is 0, 1, 2, 3, 4, 5, 6, and 7. So your
1, 3,
SOP,
4, and 5.
yeah, SOP form is 0, 2, 6, and 7. But what they're asking is POS. So POS wherever are whatever are the remaining numbers, wherever there is not one, that is your POS. So like this one, this one, this one, and this one. Rest all have ones. So in POS you will have 1, 3, 4, and 5. So your answer will be C. Is it clear to everyone? All right. Next question is, the following KMap represents a Boolean function of 4 variables. What is the minimal form of the function? So they have already given you a drawn KMap. You have to give the answer. So please attempt this. So I will write the, what is this? This is A bar, B bar, A bar, B, A, B, A, B bar. This is B bar, sorry, C bar, D bar, C bar, D, C, D, C, D bar. Now you can maybe solve it easily. Okay, so we have got one answer. It is A bar B bar plus B bar D is plus. Okay, it's correct. So we just have to form the groups. So this is one of the largest group that I can see. A bar B bar. Next, I can form a group. These two. This is what is this? This is A. This is CD bar. This is ACD bar. Then we have a group here also, right? These two and these two. We can so this is B bar, this is B bar, and this is both are D. So this is D bar D. So answer is A bar B bar plus B bar D plus AC D bar.
Yes.
Okay. Is there any doubt in this one? Is it clear to all? All right. So next question is again for schema. But now here we see there is something different in this schema, right? You see there are cross also. So we call this cross as don't care case. So what does this mean? It does not matter whether it is you take it as 0 or 1. It does not matter. So if you need cross to be 1 to make a group, then take it as 1. Essentially what it is saying, if you need this cross, let's say you have a K-map somewhere where you're seeing cross, cross, cross 1 in middle. You can actually form a group out of this, assuming this cross to be 1, right? So that is what these crosses mean. But let's say these are some crosses also here, but no one is there to help for making a group. So we will not form a group of these. We do not care about these. We only care about the ones. If there is someone which needs its help to make a group, then we will make a group. This is correct. This is wrong. Okay. So people. Okay. Yeah. Second option is correct. So let us make the groups here. So one group, the largest group I can see is here. One, 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 and one. This is one group. Oh, sorry, these two cannot be. This is not the last group. This is just one group. Mistake. This is one group, and this is B bar, C bar, D bar. Then this is another group. It is B bar, C D, and we can have another group here. This is B, C bar, D. So your answer is B bar, C bar, D bar plus B bar, C D, B, C bar, D. So which is option C. So, right, as per our convenience, we took this one with this cross to make a group of two. So one might say I can make a group like this also, but is it correct if I make a group like this? If you already have this group, do you need to make this group?
Needed.
No, right? This is redundant. We do not need this. We already have this. Okay, so is there any doubt in this one? Shall we move ahead? Great. Again, very same question, just for practice. You guys solve this one. I won't solve this one. There's a lot of possibilities here for the groups now. All right, first option is correct. Okay, so let us see this one. You have multiple possibilities of groups here. First, I can say is this one. So first group is this one. This is C. Next group I can make is with this one. And this is D. Third group is this one. This is AB. The answer is AB plus C plus B. Option 1. Is it clear? Good. Okay. So now we have an interesting question. Given given F1, F2, F3, and F4 in canonical SOP form of the circuit, right? So then W is. You know what is F1, F2, F3, and F4? You have to find the expression for W. Attempt this, then let us solve it. Is anyone attempting this? Do you know? Is anyone attempting this? Are you making any progress? Or you want me to solve it?
Solve it, sir.
All right. So first of all, let us see these gates. So what is this? This is an OR gate. This is an OR gate. This is an AND gate. Right? So I hope you all know what is OR gate and AND gate. So OR gate, if it is A, B, and F, or I should write A or B. This is A or B, right? 0, 0, 0, 1, 1, 0, 1, 1. Then wherever there is 1, you also always get 1 as the output. This is OR gate. Right? Next you have AND gate. AND gate, if you see A dot B, 0, 1, 1, 0, 1, 1. So wherever there is AND gate is 1, only all are 1. 0, 0, 0, it is 1. So this is AND gate truth table. Okay, so here what you have is you have F1 or with F2, and then it is okay. Let me write it in next page. Clear. I can write it here. What is W? W is F1 or with F2. This ended with F3 or with F4. Right? This is W. This is what we can easily read from this circuit, right? So now how to do F1 or with F2? So what is F1? F1 equals to sigma 1, 2, 3, 7, 8. 1, 2, 3, 7, 8. F2 is 1, 6, 8, 15. 1, 6, 8, 15. Okay, so what is F1 or with F2? It is whatever all the total number of terms that you are getting in this, that is OR, right? So why I'm doing this? Because you know when we write this when we have, let's say, written in some previous question, uh, if you remember, this is 0, 2, 6, and 7. Why did we write this? Because 0, it was 1 here at 0, at 2, at 6, and 7. That means at all these terms there is a 1. Similarly, if you see here at all these terms 1, 2, 3, 7, 8, there is a 1 in F2, F1. Similarly for F2, there is 1, 6, 8, and 15, there is a 1. And OR gate says wherever there is a 1, the answer OR gate will have a 1. So in all of these numbers there is a 1. So F2 is simply all the numbers together: 1, 2, 3, 7, 8, and 1 is already there, and 6, 8, 8 is already there, and 15. So this is F1 or F2, right? Similarly, let me write it here. You have F3 and F4. F3 is 1, 6, 7, 8, 9, 15, and F4 is 1, 3, 5, 12, 13, 15. So F3 or F4 will be all the terms coming in this: 1, 6, 7, 8, 9, 15, then 3, 5, 12, 13. 3, 5, 12, 13. So this is F3 or F4. Now I'll just write them together. We have F1 or F2, which is I'll try to write it in ascending form. F1 or F2 is 1, so 1, 2, 3, 6, 7, 8, 15. You have F3 or with F4. It is sigma 1, 3 is there, and what is there else? 6 is there, 7 is there, 8 is there, 9.
5 is also there.
Oh, yeah, right, 5 is also there, sorry. So I'll just try to make space and get lighted in next page. F1 or F2, F3 or F4, 1, 2, 3, I'll use space for 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right? This is F1 or F2. F3, you have 1, 3, 5, 6, 7, 8, 9, 12, 13, 15. Now you have to AND these two. Now ANDing will be AND is 1 only when both are 1. Right? So both are 1 here, 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 and here. So your ANDed answer, I'll just mark these again. This, this, so your answer W is sigma 1, 3, 6, 7, 8, 15. Which is this option. Is it clear to all? Just have to remember two things. In OR, whatever numbers are coming, just write them all together. That is your OR. In AND, you just have to take the common ones. Is there any doubt in this question? All right, then uh, let us see the next one. This is a very interesting question. So consider a circuit with three inputs X, Y, and Z and three outputs A, B, and C. So let's say we have some circuit. We have three inputs X, Y, and Z, three outputs A, B, and C. When binary input is 1, 3, 5, or 0. So what this is mean? This is your input, right? X, Y, Z. So X, Y, Z can be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 1, 1, 0, 1, 1, 1. And our outputs are A, B, and C. And I'll write just the numbers also. This 0, 1, 2, 3, 4, 5, 6, 7. So the question says when the binary input is 1, 3, 5, or 0, the binary output is 2 greater than the input. So when input is 1, 3, 5, or 0, output is input plus 2, that is 3 5, 7, and 2. So for input 1, your output is 3. So I can write input 1, output is 3, 0, 1, 1. Input is 3, output is 5, 1, 0, 1 here. Here input is 3, output is 5. Here input is 1, output is 3. Then we have input 5, output is 7. Input is 5, output is 7. Then input is 0, output is 2. 0, output is 2. Is this clear? Okay. So next they say when input is 4 or 6, output is 3 less than the input. So when input is 4 or 6, output is 3 minus input, right? So that is, sorry, input minus 3, that is 1 or 3. Input is 4, output is 1. Input is 6, output is 3. Next, what they ask is when input is 7 or 2, output is same as the input. So if input is 7 comma 2, output is either also the same number. Input is 2, output is same. Input is 7, output is same. Okay, so now this is the final table. Now what they ask is find the expression of A. Okay, that we can do. So the only interesting that is not you have seen some part is making this table. Is the table clear to all? Okay, so now you have to do is find the expression of A. For that, just consider this and make the K-map, right? For the your inner K-map, there will be these three terms. So let us do that. I'll just erase this and make it here itself. X bar X, Y bar Z bar, Y bar Z, Y Z, Y Z bar. So this is 0, 1, 3, 2, 4, 5, 6. So for A, you have one set here, here, and here. This is 3, 5, and 7. One at 3, 5, and 7. So you just need to make these groups. One group is this, one group is this. This is YZ, this is XZ. So your answer is XZ plus YZ. It's this. Is this clear to all? Okay. So the next question is find the expression of B, and after that the question is find the expression of C. So I'll just open the table for you. You guys make the expressions for B and C yourself and let me know the answers. Arpit, do you have a question?
No, sir.
Okay, I'll just remove this color to avoid confusion. Can you please show the question? Question is find the expression of B and C. This is the question. For the same data in question 15, find the expression of B and find the expression of C. Options I will not give you. Just tell me the answers. So use this truth table and find the expression of first B and then C. Just like we did for A here. Same thing you have to do. Sorry, I think I was speaking mute. Yeah. So what you have to do is find the expressions for B and then for C. Just like we did here for A, right? We made this truth table. We made this K-map from this truth table. Same thing you have to do for B and C. So that is the question. Find the expression for B and find the expression for C. So you just need this truth table. Anyone got the answer for B? Anyone got the answer for B? What is B? Okay. So let us verify this. I'll make the K map again. I will make it for C also. I should have written X5. I'm sorry. So for B, you have ones in 0, 1, 2, 5, 6, 7. 0, 1, 2, 5, 6, 7. And for C, you have in 1, 3, and so on. 1, 3, and all these. So for B, what will be your expression? You have one group here, one group here, and one group here. So this is xz, this is x bar, y bar, and this is yz bar. So B is x bar, y bar plus xz plus yz bar. And C is these four and these four. So this is x, this is z. C is x plus z. Right. So I think all of you got the correct answers. I hope this question is clear to everyone. All right, then let us move ahead. These two we have solved. Now let us see the answer was C was x plus z and B was x bar y bar plus yz bar plus xz. I think Arpit, you have got the wrong answer. Do you know where you have made the mistake?
Yes, sir.
Okay. Actually, yours could also be correct if I see. Can we make a group one here, and one here? Yeah, I think your answer could also be correct. We can also make the group B as x bar z bar plus y bar z plus x y. Is this what you're getting? No, this is still not your answer. Anyway, so I just made another group. This we can make this, this, and this. These three groups also. So there are again multiple ways to make groups. So be mindful of that. So B, both are correct. All right. Okay, next question is simple. How many entries will be in the truth table of 4 input NAND gate? 16, right? Because 4 input, you have like 4 input A, B, C, and D, and their NAND answer Y. So with 4 variables, you can have 16 possible combinations, right? 0, 0, 0, 2, 1, 1, 1, 1. This is 0 to 15. So our answer is 16. Okay. Next question is, what is the minimum number of 2 input NOR gates that are required for implementing 2 input XNOR? Please think about it. Do you guys know what is XNOR gate? Yeah, let me just tell. I'm not sure if you guys know what is NOR and XNOR. So NOR is simply A, B, 0, 0, 0, 1, 1, 0, 1, 1. So OR and NOR. OR would have been 0, 1, 1, 1. NOR is just opposite of this. 1, 0, 0, 0. So NOR is 1 when all are 0. And you also have XOR and XNOR. 0, 0, 0, 1, 1, 0, 1, 1. So XOR is 1 when inputs are different than each other. Whenever inputs are same, output is 0. XNOR is opposite of that. Whenever inputs are same, then only it is 1. This is XNOR gate. Question is asking how many NOR gates do you need to form the XNOR gate. So if you know NOR and NAND are universal gates, we can make any gates out of these. So the question asks how many NOR gates do you need to make XNOR gate. Okay, so this is something that you should remember. So how to make other gates from NOR gates, NOR to any other gates, right? I'll write all of them for you. So let's make first. So this is your NOR gate, right? Okay. So first, let's say you have to make OR gate. Then you have to do A, B, another NOR. This is your A plus B. To make AND gate, this AND. You have NAND. NAND is simply AND gate. You put another at the end. Then you have XOR and XNOR. Let's make XNOR first. And XOR is simply this plus one more stage. So the question asked how many NOR gates you need to make for XNOR? Answer is 4. Now I'll just flash them one by one and I leave it to you to actually solve this if these are correct or not. What I mean by like this simply is when inputs are shorted, this acts as a NOT gate, right? So it is simply here it is A bar, B bar. Then you're doing NOR of A bar and B bar. So NOR of A bar and B bar is simply A bar plus B bar whole bar. This is A bar dot B bar, which is AB. Similarly, you can do here. Here you're getting AB. This is AB bar, right? NOR you can also solve. This is A, B. Here it is A plus B whole bar. This again A. This is B. Here your answer is A plus B whole bar plus A whole bar. Here it is A plus B whole bar plus B bar. Solve this. It is A plus B dot A bar A plus B dot B bar. And we just multiply this A bar will be 0, so it is A bar B. This is A B bar. You have A bar B here. You have A B bar here. So yeah, XNOR is A bar B plus A B bar whole bar. Right? This is XNOR. A bar B plus A B bar is XOR. So you have A bar B plus A B bar whole bar here, and you have A bar B plus A B bar here. This is XOR. Expression for XOR gate. Is this clear to all? Deena, Harshad, Arpit. Okay. All right. So I recommend you to learn something like this for how to make any gate with NAND gate also. It is very similar. So like the configurations are all similar. Just in each of these configurations, just replace NOR gate with NAND gate. Then see what expression you are getting. So among all of these combinations only, you will get NAND to any other gate very easily. Okay. So try to remember this. It is beneficial if you want to give like exams like GATE or any other higher level examinations. These questions are very handy there. Okay. Next question is which of the following gates is equivalent to the given circuit? This is not, this is nor, not, nor, or NAND. So you just have to solve this and get the final result. So if we see here, you will get a bar, a plus b whole bar here, b bar, it is b plus c whole bar. So or it is a bar plus a bar, a plus b whole bar. This is b bar plus b plus c whole bar. You can also convert into De Morgan's, but what we can do here is a bar plus a b. This will be b bar plus b bar b bar. This will be b bar plus b bar c bar, right? This is De Morgan's theorem. Right? This a plus b whole bar can be
R gate, sir.
okay. And next is NAND. NAND is simply a dot p whole bar. So NAND of this will be, okay, let's look a bar plus a plus b whole bar dot with b bar plus b plus c whole bar. Solve it. Are you all getting A plus B? Please let me know if I made some mistake here. I do not have the answer to this question. I'm getting R, and A plus B is the simplified answer. Okay, is there any doubt in this one? Okay. What is the output F in the following question? Okay, so here you see these two bubbles, right? What this means, this is an AND gate, this is an AND gate. Then essentially you have a NOT gate, then you have an OR gate. Same thing here. Bubble always means NOT. A, B, C, D, answer F. This is A, B bar, C, D bar, A, B, C, D. Answer simply A, B plus C, D. Is this one clear? Okay, so I think this is the last question that I have for today. Which of the following is not an essential prime implicant of the function a, b, c plus d? A, B, C, D is this. So what is prime implicant and essential prime implicant? So essential prime implicant is basically groups in K-map which have at least one unique one. So what you have to do is make K-map, then you will see. So let us make it together. So this is the K-map. Now just fill these numbers 1, 4, 5, 10, 12, 13, 14, and 15. Then you have to make groups. This is one group. This is another. This is one. And this is it. So what are all the essential prime implicants? So you see all of these have at least one unique one which is not shared with anything, right? See this one is alone in this group, not shared with any other group. Here this one is alone in this group. Here in yellow group, this one is the one that is not shared with any other group. Here this is the one which is not shared. So all of these are essential prime implicants. So I'll write all the APIs. This is A, C, D bar. So option B is incorrect. This one is AB. Option D is incorrect. This one is uh, B, C bar. This is not an option. This one is A bar, C bar, D. This one is also incorrect. The last option is B, C bar, D. So what is B, C bar, D? This is B. This is C bar, D. So they're saying this group, is this group an EPI, essential prime implicant? No, because if we make this group, it already has ones which are already shared with other groups. It has no unique one. So not an essential prime implicant, your answer is option C. Rest all are essential prime implicants. Is this clear? What are essential prime implicants? Just mark that one also. Is there any doubt in this? Okay then, so these are all the questions I had for today. If there is any doubt, you may please ask, else we will close the session for today. In terms of circuits, what is implicants? So if you think in terms of circuits, if I add this BCD, B C bar D, what it will give you is just one additional term. So currently your F is AB plus AC D bar plus BC bar plus A bar C bar D. So let's say this is your minimized expression for this function. Now, if you add this another term, B C bar D, now you go on making a circuit for this. So what will happen is you need one OR gate for, sorry, one AND gate for AB, one for A C D bar, one for B C bar, one for A bar C bar D. Then you add another, if you consider it, B C bar D. Now you just send all these outputs to an OR gate. That is your function. Now you take something that is not essential. This is not essential. You are just adding unnecessary circuitry, right? And further, so you need one extra 3 input AND gate, as well as you, instead of 4 input OR gate, you need 5 input now, right? So these are like just like if you only keep those essential terms, then you will have your minimized circuits also. Okay. Is there anything else? Okay then. Thank you everyone. We'll see you next week.